Okay, so I wanted to take problem 678, number 48, because there were some differences of opinion on how that worked and what the right answer was. And it says there's a semi-elliptical arch through a railroad underpass, has a major axis of 32 feet. So let's go ahead and sketch that in. 32 feet. So that says this distance is 16, which is A, because this is a semi-ellipse. And then it has a height at the center of 12. So we'll draw that like so. So that's B, right, from the center to on the minor axis. And it asks us to identify the coordinates of the known points. So that known point is 16 and 0. This known point is minus 16, 0. And the apex of this arch is 0, 12. Okay? So since, again, we know it's semi-elliptical, then we can just write the equation for this rascal as x squared over 16 squared plus y squared over 12 squared is equal to 1. Right? No problem. That's A and B of this ellipse problem. Now, it asks us, will a truck that's 10 feet wide and 9 feet tall be able to drive through the underpass without crossing the center? Okay, so that says we're going to have a truck about like that, that's 10 feet wide and 9 feet tall. Will it fit, or does the driver scrape the corner off the truck? So how do we do that? Well, the easiest thing to do is just plug that into our equation. Y squared over 12 squared is equal to 1. We have a point 10 feet in the x direction. If we plug that in for x squared, we can solve for y and see if that's greater or less than 9, which is the height of the truck. So we'll do 100 over 256 plus y squared over 144 is equal to 1. So y squared is equal to 1 minus 100 over 256 times 144. And we get out our handy calculator. And what is that? Times 144 is y squared is 87.75. So y is equal to 9.36. Okay, so we go back here and it says that this point right there is at 9.36. The truck is only 9, so it just barely fits, right? Okay, that's how that kind of problem works.